Hello, everybody. Thank you for your patience this week. Um, Hopefully this shift kind of opens things up for you a little bit and it ends up being mutually beneficial. But um, either way, thank you for your patience. I expect to be in class on Friday. So anything hands-on you need to see, we can dive into that. And if you have any questions, let me know. You can still ask questions here. I'll have you all automatically on mute. Um, If I ask if there's any questions, don't feel the need to unmute yourselves. If I get no response, I'll assume there's no questions. Okay, so the first thing I wanted to bring up is our next test. So let's go to your syllabus. I had it up somewhere. It's one of those days. So I think the next test is going to be the 27th. So it was between the 24th and the 27th. Not solid on the date, but it'll be between those two dates. When the second quiz is, I'm leaning towards the Friday date. Um, but we can take a vote on that when we get back in class too. Just know that it is kind of coming up, but you do still have a little bit of time before we get there. Um, it'd be either 2 weeks, most likely 2.5. We can just say that right now. We'll say it's the 27th. Your next test is the 27th instead of me stalling on making a choice. Okay. The next thing is your responses, your feedback survey. So, first thing, what do you need help with? Just some more practice with I's, J's, and K's. You can think of them as X, Y's, and Z's, almost interchangeably. Maybe interchangeably is not the right term, but I'll label our X's, J's will label our Y's, and K's will label our Z's. But we'll get in more practice too. Need some more practice on questions with moving moments, which is still the topic for this week. Kind of. So we'll go into more of that. None. 3D vectors needs a little bit more time, and couple systems needs a little bit more time. Couple systems, for sure, we'll get into 3D vectors. I'll put a little extra emphasis on that today. That's that same. So this is all the same person, the IJs and Ks and the 3D vectors. But usually if one person says it, it's multiple people. And then spending more time. So perfect. Question so far. Cool. So in lieu of those vector questions, I want to revisit this homework question. So we're looking at 3 cables are connected at A. So remember, when we turn this into a free body diagram, we're going to put tension on all of our cables, meaning they're going to be going away from our A vector. Knowing that Q equals 0, essentially it's not there, find the value of P, for which the tension in cable AD is 315 newtons. I went in with our equilibrium equations. We're not really in the equilibrium part of our moments yet, but we'll get there. But essentially, the sum of the forces in any direction is going to equal the summation of all of our tension forces plus P and Q if Q had a value, but it doesn't. So in terms of getting your directional values, use the physical geometry, the point locations, to tell where your vector is going. So your force is going to go along the line of any cable or anything like that. So your force unit vector, right? Our unit vector tells us the direction. Our unit vector for our cable is going to be the same as the unit vector for our force. I'm going to come back to these values in a second, but I wanted to go to this equation up here. This is like one of the base ones. The unit vector of any vector is equal to its distance vector or its displacement or its location divided by its magnitude or its square root of its sum of its squares. These, right, our magnitudes. In terms of our physical geometry, so we have point A is at 960 millimeters along the x-axis. We have it is 240 up on the y-axis, and it is 0 along the z-axis. It's still lined up with that x-axis. It's not shifted forward or back. B is along the z-axis, so its x and its y are 0, but its z element is 380. C, so think of these points, right, are an x, y, and a z location. So these are all their x, y, and z locations. C equals, again, on that z-axis, only negative 320 this time, negative 320, 0, 0, negative 320. And D is along, where is D? D's up here. D is on the YZ plane, which means it has a 0x value, right? We're not adding any, we're not moving in this direction at all. 0x value, 960 Y value, and sorry, I thought I made a mistake there, but I didn't. 960 Y value and a negative 220 Z value. So those are the locations of the physical points that we're getting by these measurements in millimeters. The distance between 2 points is going to be, or the vector that connects them is going to be the difference of them. So let's say we want to go from A to B. We're going to take point B and we're going to subtract point A from it. That's going to give us the vector that goes from A to B. That being said, I always forget, do I subtract A from B or B from A? Which direction does it go? What happens is, like, let's say we chose to do, so here we're going B minus A, when we get our negative X value, negative Y value, and a positive Z value. When we look at our A compared to our B, we want our vector to go in this direction. That's going to be going towards negative X, towards, it's harder to see the Y here, but this is a 240 Y and a 0 Y, so we are going down in our Y element. And our Z element, we're coming forward, so that's going to be positive. So if I get negative, negative, positive, I know I did it right. If I get positive, positive, negative, I know that that doesn't make sense for this to be in tension, and so I can switch those values. Are there any questions there? Okay, so we subtract the points and we come up with our circular brackets are our points, our square brackets are vectors. So this is negative 960I minus 240J plus 380K. Or in other words, negative 960 along the x-axis minus 240 along the y-axis plus 380 along the z-axis. Questions? Okay, so to get to our unit vector now, we have all of these distance vectors, all of the actual locations of our threads. We want to divide that by their magnitudes. Their magnitudes are the square root of the sum of the square. When we were working with x and y, it was the square root of x squared plus y squared. When we're working with x, y, and z, it's x squared plus y squared plus z squared. Square root of all of that. Our values come out, so here is the actual math on it. So, pardon me. When we are using unit vectors, it's a little bit less significant what units we're using because all of these are in millimeters and we're dividing by millimeters. So our end result will be unitless, which our unit vector is. The fact that our unit vector is unitless, it means we have to worry about those less. Once we go into moments, then we have to be more cautious to be working in meters so that our newtons and our meters make sense. So our units all line up. Okay. Unit vector for each is going to be its vector itself divided by its magnitude. What we would do is we would distribute this magnitude, the division of the magnitude to each term. So it would be negative 960 divided by 1060 in the I direction, minus 240 divided by 1060 in the J direction or in the Y direction, plus 380 divided by 1060 in the K direction. We come up with this. Repeat that with each thread to get their unit vectors. And then once we have the unit vector, so if we rewrote this, we could say that the unit vector times the distance magnitude equals the distance vector. Distance vector has all of our information in it, our direction and our magnitude. But our unit vector only has direction, our magnitude only has magnitude. So if we multiply those together, we get our distance vector. The same thing is going to be true for our tensions. So these equations are the same, it's just rewritten, right? And multiplied by the magnitude. So the force vector or the tension is equal to the magnitude of the tension times that unit vector. That unit vector is going to be the same as the thread direction. And so we're going to find that. So then knowing the force, we can find, if we know the tension, we can find each element of it, right? We can find the tension vector. If we don't, like in this case, it was ending up, you wanted to solve for some unknown value. So then you go from there. But this is uploaded. So if you want to check out these first three resources, it's this uploaded online.